Okay, example 1. The tires on a rental car fleet have lifetime that are normally distributed with a mean, with a mean life of 64,000 kilometers. So mean is 64,000 and it has a standard deviation of 4,800. Okay, every week a mechanic checks the tires on 10 randomly selected cars. So this is the number of trials, n equals 10, right? So in regards to the 10, what we're going to do is this is just a sample. It's not a population. So we're going to use S and we're going to use X bar. So what are the mean and standard deviation of these samples? So the mean is going to be the same. The mean is going to be the 64,000. Now, the standard deviation we have from the previous slide. And this one's sigma over root n. Okay, so let's go sigma over root n. Now, n, we did the tires on 10 cars. So because there are 4 tires on each car, n can actually be 40 for this one because it's just the 10 times 4. So our sigma, which is 4,800, and then we're going to divide it by root 40. And if you just punch that into your calculator, we get 750, let's just round to 759 because it's 758.946, okay? 759 would be our sigma. Now, B asks, how likely is the mechanic to find a sample mean of 62,500 kilometers or less? So this was the 64. So we're going to go 62.5. And we're going to take a look at that. So what's the probability that X is less than 62,500? Okay. So let's use mu and sigma again. Those. X minus mu over sigma. So we have X, which is our 62,500, minus our 64,000 over 759. And when we put that into our calculator, I get a z-score of negative 1.98. We'll round it. So let's take a look at that on our z-score chart. Okay, so we're looking at negative 1.98. Negative 1.9 is here, and 0, 1, 2, 3, 4, 5, 6, 7, 8. I get 2.39%. So going back to this, I get 2.39%. And if you want to check if this is logical or not, I would take this 64, and I would see how many standard deviations away from the mean is 62.5. So I would say that 64,000 and subtract 4,800. And then subtract 4,800. And then just take a look. What is almost 2 standard deviations less than the mean? Because remember, the z-score is how many standard deviations away from the mean something lies. And if something lies 2 standard deviations away from the mean, say almost like -2, then if we remember just by common sense, 1 standard deviation away from the mean is 68% of the data. 2 standard deviations away from the mean would take it to 95% data. So from here to here, and then from here to here, what would be missing is 2.5 on this side, and then 2.5 on this side. Just like the highest 2.5% and the lowest 2.5%. So this makes a lot of sense there.